Yeah, I'm going to talk about web codecs by not talking about web codecs. I'll talk about the thing around web codecs, which you mostly have to deal with when you work with it, and it's about media containers. And if you want to click on the links in the slide, you can just go there, but you don't have to right now. You will get the link later on as well. So yeah, as you already know, my name is Christoph. I'm working on multimedia applications in the browser, so I cannot say anything about doing things outside. I'm just doing stuff inside, and I do this long enough, so I eventually became an invited expert at the audio working group of the W3C, and I also do a couple of open source projects which somehow always deal with media and standards. And yeah, I will put in a little shameless plug in my presentation. So as I said, when working on media projects in the web right now, you deal with a lot of APIs, but web codecs is one which I used fairly recently, quite often, fairly recently. And yeah, if you are not lucky to work with media over QUIC, you mostly deal with, let's say, legacy files, which you have on your file system that do not only contain the media, they also have a container around it, and naturally you have to pass that container to get to the media. And yeah, so it's a very common problem, and so the natural thing to ask for is, can we just have an API for it? If we have web codecs now, why is there no web container? And actually, people asked for it. It's issue number 24, so it was asked quite early, and it was a very popular issue. But it was eventually closed as a won't fix, and I was not involved in the decision, so but I can somehow imagine why it was made, and I hope you also come to the same conclusion in a few minutes. But before that, let's quickly answer that basic question: what actually is a media file? And if you think about it long enough, like if you spend 8 hours on a train, for example, you kind of realize that this is a philosophical question in the end. Like anything is a media file, but from the web codecs perspective, it's only audio and video and also images. But images are dealt with in a special way. They get their containers passed because the containers of an image are mostly very, very, very tightly coupled to the codec, so that's handled differently. But yeah, from the perspective of web codecs, it's only audio and video, and I also realized that this is a conference for audio and video devs, so it actually fits quite nicely. And yeah, this is the codecs that should be supported by web codecs, and they are not actually in the spec. They are in a separate thing called a registry, which is to allow further codecs to be added later on when the web codec spec is finalized. Well, most probably it will never be, but if it's in a stable state, then adding new codecs will be fairly easy. Like when AV2 comes along, and in some years down the line, then it can be added. And actually, I have a little project which kind of replaces the web codecs API. It's a drop-in replacement. If the API is there, you can use it. If not, it will provide the same API, like you can use it on Node.js. But if the list of codecs there was no codec that you like, you can use that to extend it and to override existing codecs. So that was my shameless plug. But now back to the topic of parsing containers. And these are just a few popular containers I came up with when thinking about that, the problem. And the reason why I put them on the screen is that if you multiply that with the codecs that you just saw, then you can kind of get an idea on the complexity of the problem. Like an MP4 can contain almost all of the codecs and WebM as well. And then the others are more specialized, but also they can have multiple codecs inside, which you might not necessarily expect. And another problem is that a codec and the container, I talked about it so far as if it would be two separate things, but in theory they are, but in practice they aren't. As I already said, for images, they are very tightly coupled, like a JPEG always has this certain file format, even though it's actually a codec, like the file format is specified as well, and the same is true for PNG, but MP3 is quite similar. Opus has a kind of a file format for standalone, and so it's very hard to draw a line what actually is a codec and what is the container. And the problem already surfaced when there was an attempt to figure out what to do with priming samples. These are the samples when you have audio in a lossy codec, then you usually need a few samples to prime the decoder to ramp up, basically. And when you do that, you have to discard those samples later on. And sometimes that information is fixed, like for old AAC files, that's, I forgot the number, it's around 1,000 samples. And for old MP3 files, you just don't know. And for a bit newer MP3 files with encoded with lame, there's a special thing in which looks like a regular audio frame, but if you actually parse it, you realize it's metadata. And yeah, it's very complex. It might be, so it's debatable if that's a problem that web codecs should deal with, or if it should be dealt with outside, because no one actually knows if it belongs to the codec or to the container. And then the containers are actually nestable, like that's not a bug, it's a feature. And that's a contrived example, but you could actually build an MP4 which contains an MP3, then has an ID3 tag in it, and then that has a cover image as a JPEG that has an EXIF metadata. And then if you took that picture, for example, with a new Pixel phone, that will be actually a motion photo, and that EXIF will point to an MP4, and then you can go all the way back again. So if you would come up with a specification for all that, you kind of have to account for the fact that this is actually recursive. And then I think the biggest problem actually is that you don't really know what you actually want. Like some people pass the media files just to get the media, which seems reasonable. Some others just want to get the metadata, and maybe you want both. And maybe you don't even know what it is. Like if you want to know the priming samples, for example, then what should it be? And on the very end of the spectrum, you could argue that something in the browser which passes media files should be spec conformant. And if the file is not conformant to the specification, then it should just throw an error. But that's not so easy, because over the years there have been many bugs and de facto standards which were the result of those bugs. Like, for example, WAV files are very old, and at the time there was a hard limit around 2 GB, and you cannot produce any bigger files. And that's kind of used as a hack when you save a WAV file as a stream and you don't know how long it is. You just set it to the maximum file size, and mostly all software interprets that as unknown file size. But actually it's not valid, because it would mean that it should be the maximum file size, and if the file is smaller, it's invalid. Yeah? And so it's actually very hard to say if that's a bug or it's a feature. And yeah, I guess you already know where this was leading to. Like, this is so complex and there are so many nuances that I think no one will ever specify it, because it's so much. Maybe an AI will generate a specification for us in a few years, but I guess until that happens, we have to do it ourselves. And yeah, the usual answer, which most of you will probably also know, is like, can we just use what everyone else is using? Like FFmpeg is used everywhere, and we probably use it right now for the live stream, and it's used inside the browser that I'm using. So why can't we just use it for that too? And the answer is we can. Like the thing inside of FFmpeg which does that is called libav format, and it does exactly what I described. It parses media files and gets out the media data, and you can compile that to WebAssembly. And at first, when you think about it, that's actually what WebAssembly was made for. Like, it's a native code base. It's very big. No one wants to rewrite it, and you can compile it with WebAssembly and then run it in the browser. But The downside is that you will end up with a very large FFmpeg build, several megabytes, something around 2 or 3 megabytes right now, and in the end it might be even slower because FFmpeg is if you need the performance of WebAssembly, then WebAssembly is certainly a good fit, but you have to, if you want to do something with WebAssembly, you have to load the bundle before, and then it has to be parsed and executed, and all the data has to be piped into the WebAssembly realm. And doing that for decoding, for example, might not be a big issue because the decoding takes so much time that the other overhead doesn't really matter. But for parsing just the container, that actually matters because container parsing is not actually compute intensive. Like it's mainly going through a file and it's more I/O bound than anything else because it just reads a few bytes here and there and passes most of the data through as is. So yeah, it might actually be overkill. And I came up with a few examples to convince you that this is actually the case. Like, as I said, you can use an FFmpeg build for any of this, and it will just work. It will work fine, but I think there's definitely room for improvement. And if you think of a typical streaming service, something that you all know, or a video platform, and they have the luxury that they actually know what they are playing. Like they know the exact file format, they know probably the bitrate and everything else, so they don't really need the full FFmpeg version. And for that, there are options, of course, to compile a certain FFmpeg version which just has the code for a certain container. But yeah, I think you could do this even more flexible by having a standalone library for that. And yeah, the library that I have in mind, or that I would like to have, would be flexible enough to do that as well. That it can be compiled and just results in the code necessary for parsing one container. And if you think this through, then you could actually do this on the server. Like if you if you have server-side rendering for the page, and you have a page which shows the video, you could server render this. And during the server rendering, you could actually already parse the file and then just include little information on where to get the data and how to configure the web codecs API. That's all it. And then you would not even need any code to parse the file in the browser. And yeah, another example would be like a music player, something like WebAmp or anything similar which just plays music. And for that, you would like to have something which plays all the files. And that sounds like a use case for FFmpeg, right? Because you need all the files. And yeah, so why not? But again, I would say if the library is flexible enough, you could use a different library before, like a very small one, like file type, for example, which whenever you see a new file, the user selects a new file, then you quickly parse it with file type just to know what it is, and then you load the tiny piece of code to get to parse that specific container on demand, and yeah, that way you will probably get a much better user experience because the site is interactive right away, and and you don't have to parse the full code. And you could even do this even a bit more elaborate by using something like the idle until urgent strategy. Like if the user doesn't do anything, you start loading a few popular libraries, the code for a few popular containers, and then when the user actually selects a file, then you prioritize the one that is needed. And yeah, then the last example is transcoding or recording app, which also sounds like a use case for the full FFmpeg thing, because if you want to record, then you probably want to have all the options available to record as many files as possible, as many different file formats. But again, you could have a default file format which is pre-selected, and then you load that code. And whenever the user selects a different format, then you just load it on demand. Yeah, so this is the wish list for a library that I have in mind. Like I wanted to be tree shakeable. That's the the fancy term of saying that if some code is not needed, it should be disappear and not end up in the browser. It should be lazy loadable, like when you don't load it at first, like you wait until you need it and then you load it on demand. It should be extendable because I showed you all the different codecs and containers, and no matter how large the library will be, there will always be a container which it doesn't handle. So there should be an option to extend it or to replace logic if needed. And it should be configurable, like you should be able to specify, for example, the size of an awk container or something. Like it should be very specifically configurable and customizable as well. Like if you don't want to pass the metadata passing should not be in the final bundle. And all that should be streamable, like you should not be necessary to read the full file to get the first information, and it should be possible to skip through the file as well. And yeah, luckily, someone actually did this before I got a chance to give this a try. Like I have a bit of code ready, but I never got around to actually publish it. And yeah, but someone else did. And the library is called MediaBunny, and it's a JavaScript implementation of many popular containers. And yeah, it works very well, and it does almost all of the things that I just said. Like it's tree shakeable and lazy loadable, and I think it could be a bit smaller in the final bundle, but it's actually really good already. It's not really extendable and replaceable yet. You can do it if in a hacky way, but I'm not sure if it's meant to be, but it could be, and it's not really configurable to a very specific way, but it allows you to configure something. Like you can, for example, say that the bit rate should be high or low, but you cannot really say what bit rate it should be. And yeah, but it's streamable and skippable, so it's actually really nice. And while I was on the train on my way here, I hacked together a little proof of concept just to show you an example. That was passing an Opus file and just running through as fast as possible. And with libavjs, which is a WebAssembly compiled FFmpeg version, that's took around 130 milliseconds, and the bundle was almost over a megabyte big. And with MediaBunny, that were only 50K, and the time it took was about 1/5 of the one which the FFmpeg version needed. And my ugly code that I put together was a bit smaller, or at least 10 times smaller. But yeah, and the performance was all comparable. But I'm not sure if it's worth spending more time on now that MediaBunny exists, and also if it's worth getting the numbers even lower, because yeah, the bundle size of MediaBunny is already quite good. Yeah, and that's it. Thank you very much for your attention. And yeah, if you want to get the slides, you can find it here. And if you want to get more information about me, you can get that on that link. Thank you.
Question time. Does anyone have anything on their mind? So I haven't been following the world of multimedia in the browser, but is it right that MediaBunny is just popped up like several months ago? Like, I don't know.
It must have been in the works for several months. Yeah, I don't know exactly, but I heard about it a few weeks ago, and yeah, then I realized at least that yeah, at least one more person had the same idea and actually did it.
Did you, because your solution is order of magnitude lighter than MediaBunny, did you compare how they did things comparing to your solution, or?
Yeah, it has. That's what I meant by it's not really customizable. Like you can select a format. For example, I did this demo with an Opus file, and I had just the code to parse an Opus file, but it still parsed a lot of information which I did not need for the use case, and you cannot throw it away. Like it only is tree shakeable on the level of a certain container, but not inside of the container.
Okay.
That's probably the reason.
Thank you for the explanation. All right, unless there are any other questions, let's give a hand to Christoph.
Thank you.